how uh, I'm building my AI search startup, and specifically on one of the important pieces that I've talked about in the past, but I'll continue to make videos on this, is how do you process the query? How do you understand the query? How do you break it down? And how do you do it in an AI native way? So I used to work for Google, and there was a query understanding team, and there was a whole effort to sort of expand the query, identify entities, and look at related queries, and then further expand and personal using personalization, sort of further try to hone in. But it was still, in the grand scheme of things, not super duper intelligent. It didn't use today's modern reasoning models. By the way, so sorry about all the noise. The place I live, there's construction and work, whole housework happening every single side, up, down, left, right, and I'm kind of stuck in the moment where I am. So sorry about all that noise. Can't do anything. I actually plan to kind of get out and go work from a hotel or something for a while, or an Airbnb, to kind of get away. It's really hard to focus. So sorry about that. But yes, so that's how Google and traditional search engines used to do things. With the advent of, modern LLMs, you now have these models that are very large, and so they have so much knowledge sort of embedded, compressed within them, that you can kind of just ask them to kind of help you better understand the query. Not only that, when you ask the LLM to help you understand the query, you can also add in the context maybe the user's previous queries if they're related. You can also add some of their memories, like something about them that they know, that we know. So if the user is an architect, it'd be nice to kind of add that in the context, so that, if there is an architect term that has dual meaning or ambiguous, just mentioning that the user is an architect may help. So the models understand, oh, they mean probably this. And then on top of that, you can use thinking models, like models with thinking enabled. Um, and that gives you even more sort of ability to kind of expand and understand, because the model will do its thinking and go uh, much, much deeper in its reasoning. Basically, it tries to reason, um, um, the chain of thought, if you will, and then try to understand, and probably should result in a better sort of query understanding. Like the output of this model call could be anything. It could be structured output for, give me queries. It could be complexity score, like how complex this query is. It could be like, hey, categorize this into um, architecture or news or what have you, media, viral, whatever you want. Tag, put some popular tag, whatever you want. You can ask the LLM to do it, and the LLM will output in raw text, like if you want that, or it can output structured output, like most models do these days, like JSON output. And so that's pretty cool. Like it makes life a little bit easier, and you have all this power. Now the big downside, the big downside, and why Google's still not using an approach like this today, at least in their default mode, is that it's expensive. These are very big models and slow. And more than expensive, honestly, it's the latency that can really affect, a company like Google, because Google users are not used to waiting for a search response. And believe me, a lot of thought goes into Google. I was part of Google search, and so I can tell. But even if you're not working for Google, you should, it's not too hard to tell that people sort of map speed with Google search. And so that's like a blessing and curse for Google, because it becomes very hard for them to evolve the product with all the user expectation. That's why if you think about how the current search results work, Google search results, you still get the same sort of search results with all the website matches, the sort of knowledge panel, if you will, some news queries, some X post tweets embedded if they match. That's all generated very quickly, mostly from cached sources in memory indexes, very, very quickly. And then the AI mode will load almost asynchronously. So the search result doesn't wait for the AI mode results. And then you don't really see it, but it is a separate column. The search page is designed such that the AI mode can fail and you'll still see a traditional Google search result. So in some ways, they kind of solved it quite intelligently. But you can argue that the utility of the search results, like the 12 search results or 10, 12, whatever, or how many, it's not a fixed count because it depends on if there are news matches and X matches and Reddit matches, then you show less results, else you show more results, all that. But you can tell whether the utility value is still there because now users are used to ChatGPT and Grok and all these models that give really good answers. And it's anybody's answer at this point. Um, According to Google executives, I would think, I mean, they haven't told me this, and I don't work for Google anymore for the last 2 years. But it's not too hard to imagine that the Google execs are still not willing to give up on the traditional way because it makes a lot of money and ads are designed for that approach. And you can't blame them, honestly. I don't blame them. But for someone like me, who's building an AI search platform natively with AI, I have a lot of options, and I'm super glad. That's one of the reasons I like doing what I'm doing. And obviously, I'm going to lean on modern LLMs and not a traditional way because I'm not going to bind them myself with fast search results. I'm not going to. There's no way anyone can beat Google. It's just not possible. Even if you have the best algorithms, Google owns a lot of the cabling and the data centers. So they truly have the infrastructure to kind of respond in ways that even if you host on Google Cloud, it'll be very difficult, very, very difficult, because there's a lot of intelligence happens in routing. Anyways, my point is not so much about what Google is doing, it kind of try to beat Google or replicate. My point is just from as a frame of reference, that's how Google would be doing it, as I see it. But for me, I can do things differently, and I definitely want to use LLMs. But the big question is sort of how to use LLMs. So here in the screen capture that I'm showing, this is something that you may be familiar with. This is if you use Perplexity, this is sort of very common. If you search for, something like best laptop for programming 2020, even though it's 2026, this document I think I worked on with AI as helper last year. But anyways, you'll see that best laptop programming, and then you'll see kind of this kind of micro iteration loop that the Perplexity will go through, and then you'll see, oh, programming laptop, and then it searches some web pages, and it finds some more related terms, and it'll sort of factor that in, and then it'll search again, and then it'll add and find more terms, and it will search again. And the idea is that you're kind of expanding your query to find more related context so that you can produce a better response. Most users will not type very long prompts, at least in Perplexity. People are still thinking like a Google approach. ChatGPT is kind of just psychologically different. People are used to typing longer prompts. But Perplexity, Google, people are still sort of very keyword heavy. And so you'll see something like this. And the reason I wanted this is just a small step in the entire query processing pipeline, by the way. This is, if you think that if I do this, I'm done and I have an AI search app or search app. No, no, this is just one of the sort of step in the pipeline. That also, if you see us up there for moderate complexity queries. The reason I have it for moderate complexity queries is if it's justified, because all of this sort of iteration costs money. So for example, for every iteration, as you can see, I have to perform a web search. That costs money, every search API call. But there are a bunch of search APIs. I like Google's custom search JSON API. I'm using that. and then EXA search is pretty good, and there are a few others all that. But those are the two I particularly like. But anyway, those calls cost money, add latency, and then you kind of extract signals. So here, users care about RAM, CPU, keyboard from that sort of article. So by the way, there is a hidden detail here that you don't see it. When you make that search API call, you may only, if you like, for example, Google's results will only give you snippets. Maybe that may be enough for you to sort of make the call, or not make the call, but I extract related terms for expansion, maybe, probably. But you can also have a follow-up step where you scrape on demand those pages, and then you get the full body if you're successful at scraping, because by default most sites will block you. You can use, and I've experimented with using proxies and all of that, headless browser. So you have to use a headless browser, and so that also renders JavaScript. And then you can use a proxy if you want to get it. But then that's a separate discussion. Now you're talking about legalities, terms of use, etc. So another approach I found out was just you can use APIs. There's some APIs I'll give you scrape content as part of the result, like Exa does that. So you can do that for just extra cost. Or like I said, you can just scrape all, if you're scraping 3 results, you can do in parallel, all 3 of them, and cache it. This is one of the reasons why search apps are not very common. The infrastructure is very expensive, very costly. Because imagine all these web pages and caching all of them. I mean, it just adds up. But that doesn't deter me from building this. But anyway, so that's the detail. So you have to do that. And then you do that in a loop. And now, how do you know how many times you want to iterate, right? There are a couple ways to go about. One is you can just have a max. And then the other way, which is more interesting, is how do I say it? You can use like a additional LLM call to just ask, is this like, do I have sufficient context to produce a good response? One thing I've learned while building this is it's very tempting to always add an additional call, an additional LLM call to kind of help you out. But obviously it adds cost and latency and just becomes impractical very quickly. So that's another way to do it. So that's one way, this is a very heuristic sort of approach. The second way is, by the way, summarize, the heuristic way is you have a fixed number of retries or some intelligent way kind of to find out how many times you want to go about through the iterations, and you go and search and expand and develop the context and do it in a loop. So your query gets more and more interesting. Programming laptop 2025, that becomes best programmed laptop, RAM, CPU, keyboard reviews, that becomes something else, what have you. So that's one approach. The other approach, which many of the model companies would be implying, I would think, I don't know for sure, but it's not too hard to guess, is just having a model sort of reinforcement learn to do this with some kind of a thinking budget. So if you imagine like the Grok model, if you're running Grok Expert 4.1, that's probably using a thinking model, a thinking word, chain of thought thinking, what have you, thinking model of Grok. And then the model is thinking, and as it's thinking, if it needs additional information, the model itself has access to tooling, function call tooling, or some other tooling, and MCP, so many ways. It's not very interesting, but the model itself has access to it. I'm sorry, but when I say the model, I mean the application running the model can configure the model that, hey, if you want information about a certain web page, let me know, or call this function tool, and you'll get the information. And so essentially the model is doing a lot of the heavy lifting. Now, this is much more robust and impressive way of doing what I described earlier, because you kind of get away from all these heuristics and kind of hand built logic. You basically are just building more and more sophisticated models with good thinking ability and good tools that the model has access to, and the model just does the rest. It'll call the right pages, yeah, until it's not satisfied. It'll just keep thinking. No, I'm not satisfied. Call more, call more, with some cap, and return. Now, I don't have access to such a model yet. I've experimented with Gemini 3 Pro thinking, Gemini 3 Flash thinking. I've not yet experienced with Grok 4.1. I don't know if I have access to it yet. And then any of the other models, I don't think I have. I mean, I know I haven't explored. But the Gemini, oh, I'm sorry, I have tried OpenAI, GPT 5.2 thinking. I think probably 5.1 or 5.2, but it was very sort of small test. Um, my my memory is fading. Clearly, I haven't spent too much time on any other model for now, other than Gemini. But what my experience with Gemini was that the thinking, the models don't expose its true raw thoughts. And that's the case you can see in the UI as well for ChatGPT and Grok, etc. Grok's actually pretty verbose. I like it, but I was feeling even that's going to be shut down very quickly. And the reason model companies will tell you they don't expose all the raw thoughts is because competitors can use the raw thoughts to fine tune their models and improve their models. Like if I have access to the raw thinking of your model, I can use that in my reinforcement. I can essentially reinforcement learn my model with your thinking, all the hard work you've done, and I'm just paying for 1,000, 100,000 calls, which is a lot, but still enough to kind of build a model that's quite sophisticated. And so that's the reason why the models don't expose the raw thoughts. And so what you see when models share thoughts are sort of summaries of thoughts. And sometimes you don't see them at all. Um, and you also don't have access to uh, function tool calling uh, during the thinking, model thinking, chain of thought thinking process. You don't. The function call tooling that's available today is after all the thinking is done, and then um, or maybe I'm wrong about this, I don't know, maybe it is during thinking process, but it doesn't appear to me it seems like the model is doing its thinking, and then it produces a summary, like a plan, and then based on the plan it identifies, do I have to call tools or not, and then it calls the tool. So Gemini definitely supports function call, function tool call. So you can say weather API, and so Gemini will call the weather API for you. But the difference is subtle. The difference is if you use the thinking model, which is currently only Gemini 3 Flash and Gemini 3 Pro, um, it's not clear to me. They don't quite explicitly say, are those function tool calls made during the thinking process or post thinking? And my guess is post thinking, where it has already made all the decision. And that's where you lose a lot of the power. And when I use Grok 4.1, and I encourage you use it, and go to Grok 4.1 and choose expert mode. And you'll hear Elon saying that expert mode is smarter than most people, most professionals, and it's probably true. You'll see that it is very smart. You can put a very vague query, and by the way, I'm sure ChatGPT and Claude also does the same thing. But thankfully, as of today, Grok is more verbose, and it tries to hide less compared to other sort of platforms like ChatGPT, etc. They're so worried about competition. So that's why I'm worried that I hope Grok doesn't follow suit. but you will see the model's chain of thought thinking. It's like you can see the model calling function calls during its thinking process. I can tell. I don't know anyone at XAI. Maybe they can confirm this, but I can tell the model is fine tuned. Yeah, I'm sorry, reinforcement learned and probably fine tuned as well, uh, such that it the model is has hooks for function call lookups at appropriate steps so that it can find more information and enhance its reasoning capability. So for example, if I give if I'm the designer of Grok model, if I want to make it super intelligent, I know that real-time information is very important. That's a great way to improve my model versus others because so many things change. If someone died this morning, you ask the model, like, without having web search or new information, you'll say the person not dead, or you'll say I don't know. Excuse me. So it's very important. So everything from analysis, research, without real time information, you can't do much. You cannot do. Um, um, yeah, you can't really answer intelligence. So that's why X platform, like the Twitter version, is so important for XAI. Like it has access to all that real time data. It's such a gold mine. Like Google doesn't have it. ChatGPT doesn't have access. I mean, you can sign up a deal, a license with X, but you'll still have to pay a lot of money. You'll have to pay through the nose to get access to the fire hose. I mean, I have access to the X APIs thanks to the X team, but it's not cheap. Um, Now, the way Google mitigates against having that sort of fire hose of sort of social media information is Google is very good at searching the web. So real time, near real time, Google can know if some website like Wikipedia was updated. So if someone died, they'll find out much, 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 much more quickly. And then also Google can find out if something's trending, like, or refresh what data it's using, right? Like we want to make sure what we show, this important query is trending. We want to show the most recent information. So Google kind of mitigates around it, but from a model standpoint, um, uh, Grok has an advantage. And so I can tell that, I guess what I was talking about was I can see when I'm using Grok expert mode, and I encourage you to use it. You'll see it's thinking, and as it's thinking, it's like, oh, it would be nice if I know more about this topic, and then I'll do a web search, and that calls the web search tool. And then once it calls the web search tool and gets the results, it'll take all that results, snippets, or what have you, semantic research the results and the content of the results, and maybe find interesting info and then put that in the context and then continue the thinking. And then it's like, oh, now I know this, but wait, I also need to know this. Like price of gold in 2024 compared to silver. That's a very interesting query. I need to know the price of gold, what was in 2024 and after one query, but then I also have to know what was the price of silver, and then I have to then compare. And so those are like multiple calls. And so during the thinking process itself, Grok can do it and then produce a result. And then it puts it, the final step, it puts it all together and produces a response. And the tools are so powerful that I just mentioned web search, which is a great tool. But Grok also uses tweets or X posts. So that's a tool I can imagine that they use. So like they'll also search X posts. And great, right? That's just searching X, which is by default, you're not allowed to crawl or scrape X without permission from the X team. So they'll do that as well. They'll do some other thing. For example, you can imagine code execution can be also one of these things. Let me run this code, do some analysis. That could be a tool, and then return. Yes, all of this takes time, and Grok does a good job of kind of showing the progress to the user. So you're not like twiddling your thumb and just like what's happening. It kind of knows, and you kind of appreciate all the hard work it's doing. That's a much better way, in my opinion, of building it. But someone like me doesn't have access to that kind of power, that model. I don't have access to that Grok's thinking level abilities, access to the raw thoughts, and also plugging in my tools, personal tools. during the thinking ability yet. But I was thinking, what should I do? Like, I'm at such a disadvantage. There's no way I'll be able to build something that's even close to what Grok can do. Well, apparently, I started thinking, and I was like, well, there's always an alternative. It may not be as powerful, at least at surface level, if you think about it, to orchestrate this via LLMs, the whole sort of process that Grok 4.1 expert does. Uh, it may not appear to be as powerful, but it can be quite powerful. And essentially, what I'm saying is that you can use an LLM, any LLM, any thinking LLM or non-thinking LLM. There are both versions I've experimented with to orchestrate this. So you do have to kind of play around and kind of do some one-shot training for certain types of queries to kind of help the LLM, and kind of some additional signals you kind of have to ask the LLM to extract. So that's the part I'm not a big fan of, but I've tried to keep the signals pretty general purpose, so it applies to most queries. So like, for example, what's the query topic, query entities, query complexity, gaps in knowledge that we should fill. You can ask that and then follow up with more calls to the web or use your tools, and then go back again. And that's what I'm showing you here on my screen. And I would be very surprised if, this is a little bit too simplistic, I admit, what I'm showing you on the screen, but it's quite powerful. And I would be very surprised if Perplexity doesn't do a version of this internally, because Perplexity also has the same problem that I mentioned earlier. It doesn't have access to the model's raw thoughts because of all the things I discussed earlier, and so it's inventing. And so I was like, Perplexity is able to do that, and I generally like Perplexity's response is pretty good. I do sometimes like Grok, kind of heavy. I'm sorry, expert Grok. Heavy is their research mode. It spins off multiple Grok agents. It's insane. That you have to try Grok Heavy for yourself. It's like ChatGPT Pro, but ChatGPT Pro 5.2 is so black boxed. It shows some thinking, but I I hate to say it, but Grok 4.1, like Heavy and 4.1 Expert, are just amazing, like really good. Uh, and 4.2 is coming soon. But what I am thinking about is Grok 5, and what will that be? Jesus. Ooh. Because they're model-based thinking and applying tools during thinking to expand the knowledge and access real-time info. Not just real-time info, but the data computing, data processing, running Python code, for example. You can do some crazy stuff. These models are essentially static. The models are static, they're frozen. But now the models come alive. It's like infusing static models with real time, and not just real time computing and sort of knowledge, and you really become sort of super capable. But anyways, that's kind of what I kept thinking. And now when I realized that this was last year, I was like, wow, now I'm back in the game, right? And so that's the approach that I am taking at this stage. And like I said, I'd be very surprised if Perplexity doesn't have something along those lines, which is you're still very intelligent, like you're still using, custom. You can, by the way, these ideally should be fine-tuned models. So they've become very good at it. I'm not fine-tuning the models for the orchestration. And specifically what I'm trying to tell you is mimicking what sort of Grok 4.1 expert does, which is like a thinking level, sort of expanding its knowledge. You can kind of mimic that with an explicit LLM call, either with the thinking model or non-thinking model. And also thinking model supports, keep in mind, different levels of thinking: low, medium, high. Like you can ask the model to think a lot, but cost more money, costs more time. Or you can ask them all to don't think that much, but spend some time thinking. So you can mimic that, is what I'm saying, with good results, very good results. And I realized after I started on that path, because that was the only option I had, so I might as well embrace it. But I realized it's actually a secret. It has a secret weapon. Like it actually can be more powerful than a model like Grok 4.1 thinking. because now you are composing different models with different capabilities in an ideal world, for example, right? Let's talk about the ideal for a second. In an ideal, the way I can design the architecture is I can string orchestrate. I don't want to say string together because that seems implies serially. I'm not talking about serial LLM calls, like do this, then do this, then do this, then do this, and loop, which is kind of similar to what I'm showing here. Here it's like loop, 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 loop until you're kind of satisfied. You can do that. But I'm talking about like true graph based, like graph like propagation for these orchestrating these multiple LLM calls. And of course, they have to converge. Um, or you can just call them serially, then, but have different phases, and which is what I'm doing, different phases. And every phase you can have some kind of for every phase you can have almost like a subroutine to kind of uh, think smart, like a thinking approach via these LLMs. How can I be intelligent for like okay, like first, like let me give an example. First step is like planning stage. When you get the query, let's plan. That could be some sort of orchestration of model calls. Then it's like execution. Okay, that could be some strings, some sequence, or some way of LLM calls. And that can be dynamic in the sense that the models can tell at the execution at runtime, do this or call this, you follow up with this. And so all of this can be programmatic and dynamic. And so what I'm describing, I know sounds a little confusing, but all I'm saying is you're building a dynamic, automated orchestration sort of system. It seems that it becomes an AI of itself. Like ideally, you'd have an own AI, your own fine-tuned AI model that's doing this, either end to end or at different phases. But you're kind of building your own AI, which is not a single model. I'm not building a Grok 4.1 thinking model that's super large, billions of params, but I'm composing my own AI. I'm building my own AI, which is just a composition of other models. And I can use open weight models. I'm not restricted to use paid models, licensed models. I can also use my own fine-tuned models. I can use few short learning models. And now that's when I started thinking, and I'm like, holy shit, this can be, it's more complicated. It's not as uh, beautiful. It's not as simple and elegant, maybe is a better word, as if you had access to a model doing it. Or maybe one or two models. By the way, I'm kind of maybe overly simplifying what Grok does. It probably also uses a smaller model in the beginning to plan and think and understand, then a bigger model respond, probably. But in the grand scheme of things, it's very model heavy. And to improve Grok's response or any of these models, when I say Grok, I really mean all the models like ChatGPT and Gemini. When they have to improve the responses, they have to wait for the next iteration, the next generation of models. Whereas someone like me or Perplexity, I'm assuming, we are able to update our AI faster because ours is orchestration based and we can do more experiments and orchestrate differently. We can introduce more models. We can introduce smaller models at certain stage, bigger models at certain stage. When we need more thinking and reasoning, we'll use a bigger model. When we just need just some classification, if I just want to classify this query, is this a news query or not, or find entities, I'm going to use a smaller model. And I'm going to use open weight models, so I don't have to pay someone. And I'll run that open weight models locally. So it's very quick. So that becomes all of a sudden very powerful. And now I think you can set the playing field, like you can level the playing field, I feel. And in fact, you can argue, and I'll argue that the approach that I am thinking and I'm following, you may end up with a better down the road architecture and possibly more powerful system over time, which is like a meta AI system. You're like a meta AI. You're like the oracle of oracles. You're using other highly intelligent models to answer, but in your own very interesting way. And at the end, what this becomes is you have your own proprietary trained, fine-tuned model that's doing all the orchestrations. It's still AI running AI, executing AI in very interesting ways. But you get to focus on the orchestration. Remember, the secret here is focus. ChatGPT, OpenAI, they have to do Grok, they have to do so many things to improve the model. We don't have to do it. Myself, Perplexity, etc. We get to use those models and pay for them. That's fine, but we get to focus on the orchestration and execution, and that gives us an edge. Focus always gives you an edge, and then this a model or multiple models that someone like I or Perplexity would build could become a game changer possibly down the road. We'll see. But anyway, I wanted to share all these thoughts. And I was even struggling to come up with a title for this video. I also don't know who would be watching this video, but for me, it's good to kind of share some of my thinking. I want to do that, and I like doing that. So that was the purpose of this video, and this little screenshot I'm showing is from one of my dogs. But yeah, it's interesting times, and as you can tell from everything I've been talking about, it's fun. It's fun building this, and yeah, it is a business that I want to build. So down the road, I also want to do a video on the end-to-end approach, and also maybe future videos on monetization and all that and things like that. But for now, I think this should do it. It's already pretty long. Thanks everyone, and see you in the next one. See ya.